in this video, we're going to talk about the first and the second topics of Chapter 10, Gas Laws. Let's take a look at this slide. This slide tells us how gas molecules generate the pressure. Okay, we'll hear the pressure of the air, the pressure of gas all the time, but where does that pressure come from? Well, here is the thing. It's very simple. It's just the collision force caused by the gas molecules when gas molecules hit a surface. Okay, so here this picture shows you a gas molecule hit the surface. That force generates a pressure, and the collision force caused by one gas molecule is very small, trivial. But if you have millions of gas molecules interact with the surface at the same time, that pressure accumulates to a observable number, and that is called the gas pressure. And here the picture on your right side tells us if you have less gas molecule in a container, then the pressure apparently would be lower because you have less collision force caused by less gas molecule. And if you have more gas molecules, of course, the pressure will be higher because you would have a stronger collision force caused by more gaseous molecules. The second slide is about the units of pressure. Okay, on your left side tells us how a barometer, mercury barometer, works. Essentially, you have a tube here. On the top of the tube, the space here, it's vacuum. It's under vacuum. In other words, there's nothing inside this headspace. And then you have a container with mercury here. And then because the air will generate pressure, right? We call it atmospheric pressure. In the normal condition, 1 atmospheric pressure will push 716 millimeter mercury into this tube. Okay, and in other words, the pressure generated by this 760 millimeter mercury column equals to the atmospheric pressure. So this one tells us the basic mechanism of how a mercury barometer works. Okay, right now, currently we have all kinds of barometer in our lab, and it doesn't have to be mercury. You can even have digital barometer. In this table, it shows us some common units for pressure. A couple of them I want to mention here is the PA here, okay, Pascal, and the PSI here, okay, and the ATM. We will use the ATM a lot for our calculation, but these are some common pressure units that you can see in the chemical lab or scientific lab. All right, so these are some basic things about pressure. Now, second topic of chapter 10 is about gas laws. And in this topic, we're going to talk about 4 gas laws: Boyle's law, Charlie's law, Gay-Lussac's law, and Avogadro's law. We'll talk about them one by one. And the next topic, in another video, we're going to talk about the ideal gas law, which is a comprehensive view of those gas laws. So sometimes you hear people talking about the sub-gas law because those gas laws focus on a narrow part of the ideal gas law. All right. Now let's take a look at the Boyle's law. Boyle's law is about the connection between the pressure and the volume. Let's take a look at the picture on your left side. Well, here it shows you that you have a cylinder, and if the volume is 1 liter, and then the pressure would be 1 atm. Okay, it can support a weight that is 1 kilogram. Now, you replace the 1 kilogram weight with a 2 kilogram of weight, then you compress the volume of the gas from 1 liter to half liter. And then if you take a look at the data of pressure, then you realize that the pressure will increase from 1 atm to 2 atm. So it looks like the lower the volume or the smaller the volume, the higher the pressure. Okay, so this picture reflects some, a basic connection between pressure and volume. And this picture on your right side give us better idea about how the pressure change caused by the volume change. Okay, so you can see that when the volume is going down and the pressure actually is getting higher. So based on this picture, it tells us that between pressure and volume, okay? Pressure and volume, that equals to, they have this kind of mathematical connection. Pressure equals to a constant divided by the volume. So that is why you have a larger volume, then the pressure would be smaller. If you have a smaller volume, pressure will be higher. Okay. All right. Now, if you reorganize this equation, multiply V on two sides, then you will get the PV equals to a constant. Okay. So this equation tells us if you maintain the temperature as a constant, temperature, when you do this kind of measurement, temperature stays a constant. You don't change temperature. Okay. So in this case, the PV, P times V equals to a constant. And if you want to go further, and if you want to talk about the pressure volume connection at the two different states, then you would have, I'll write it here, P1 V1 equals to P2 V2. All right, so that tells us 1 and 2, there are two different states, but as long as the temperature of the two states are the same, then you have the pressure volume of the state 1 equals to the pressure volume of state 2. That's what Boyle's law means. All right, this is the first one. Now, the second one, Charlie's law. Well, Charlie's law is about the connection between the volume and temperature. Well, you can see that this picture on your left side tells us, if you increase the temperature, the volume will increase. Well, the different lines here tells us when the mole number of the gas changes, how that's slope change. Okay, that's not our focus. You just need to focus on each line. Okay, well, when you focus on each line, all of three, at least the three lines here, tells us higher temperature, higher volume. All right. Now, so that's mathematically, how does that look like? Well, you would have V equals to a constant. Remember, when we would just use a constant to tells you that V equals to a certain number times the temperature. Okay. Right now, we don't need to care too much about what the constant is. That's not our focus. When we talk about ideal gas law, we'll talk about some constants that's important for us. Okay, right now you don't need to care too much about what this constant is, as long as you know that this is a constant. Remember also, when you change the temperature and volume, when you study Charlie's law, pressure stays a constant. So that's part of the constant we are talking about here. Anyway. So you can see that based on this equation, higher temperature, higher volume, lower temperature, lower volume. And if you reorganize this equation, it will give you V divided by T equals to a constant. And again, like we did for Boyle's law, if you are talking about two different states, state 1 and state 2, you will have V1 divided by T1 equals to V2 divided by T2. All right. Okay, so this is Charlie's law, and this picture shows you that's how you inflate a balloon, huge balloon, and so you just need to heat it up. When you heat it up, the air inside the balloon will, increase its volume, so the balloon will get bigger and bigger. So eventually, it will fly to the sky. So this is Charlie's law. Now the next one is Gay-Lussac's law. Gay-Lussac's law is talking about the connection between pressure and temperature. All right, so here this picture shows you you have a temperature here. Okay, so those molecules are moving around, with a certain speed, kinetic energy, if you happen to remember, and it can support a weight here. And if you increase the temperature 3 times, then you can support 3 weights in this case. Why is that? It's because when you increase the temperature, those molecules will move faster. And when those molecules move faster, they will have a higher kinetic energy. The molecules with higher kinetic energy, when they collide with the surface of this container, it will generate a stronger collision force. That means higher pressure. All right, so that tells us higher temperature, higher pressure. So mathematically, the connection between the pressure and temperature is P equals to a constant, again, constant, times temperature. Okay, when we see constant, for instance, when we talk about the Gay-Lussac law, we're going to take a volume as a constant. Can you see the volume of those two pictures? They stay the same. Reorganize this equation like we did for the previous two laws. That will give you P over T equals to a constant. All right, and again, if you are talking about the two states, then that will give you P1 over T1 equals to P2 over T2. Okay. All right, so this is a Gay-Lussac's law. The last one here is Avogadro's law. Well, this law is about the connection between the V, the volume, and the mole number. Picture shows us this trend very clearly. If you have more the mole numbers, then the volume will increase. This is quite obvious, right? Because when you increase the mole number, that means you are increasing the number of the gaseous molecules. When you increase the gaseous molecules, of course, the volume will expand. That's it's quite obvious. So if you want to use the mathematical equation to reflect the connection between the two, and that is going to be volume equals to a constant times N. Remember, N is the mole number. And reorganize this equation, V over N equals to a constant. Here, constant tells, means, is pressure and temperature should be at the same. All right, okay, let's talk about the V and N at the two different states. According to the equation here, V1 over N1 equals to V2 over N2. All right, so these are the 4 sub-gas laws. And when you come back to class, we will do practice. Okay, we will use those equations to do some calculations. All right, let me know if you have any questions.